Hi, welcome to this M1 video on constant acceleration formulae 2, part 2. So, from the last video, we looked at how you derive these two formulae. So, V equals U plus AT and S equals U plus V over 2 times T. And what we can do is we can use these two formulae to create a few more formulae that we can then use, okay, without kind of resorting to these two. You could essentially do every question with just these two formulae, but by creating the new formulae, it enables us to speed up that process. So that's what we're going to look at first, and then we'll look at a few examples. So for the first formula that we're going to do, I'm going to rearrange V equals U plus AT to make T the subject. So this becomes V minus U equals AT, or T equals V minus U over A. And then I'm going to substitute that into this formula. So S equals U plus V over 2 multiplied by V minus U over A. Now, multiplying by the 2 and the A gives me 2AS on the left, and then expanding my brackets, I get, so UV minus U squared plus V squared minus UV. Okay, so that's just going to end up giving me V squared minus U squared. Difference of two squares there. And then taking the U squared to the other side leaves me with V squared equals U squared plus 2AS. And that is the first of my next set of formulae. And this formula eliminates T from the expression. Okay, so this one is no T. Now, for the next one, I'm going to substitute this into this equation. So I'm going to substitute this in here. And that gives me S equals U plus AT times by T all over 2. So that is 2U plus AT times by T over 2. And then expanding the bracket and dividing by 2 will give me UT plus a half AT squared. And that is my next formula. And this one has no V in it. Now, when I was in school, these are the four that we used. We didn't create this next one, but it is in the book and it is useful. I just found that the majority of the questions just involve these four, but we will look at the final one now. So this one is to eliminate U, and what we're going to do is rearrange V equals U plus AT. So this becomes, let me see, sorry, U equals V minus AT, and we're going to substitute it into this formula. So S equals V minus AT times T plus a half AT squared, which gives me VT minus AT squared plus a half AT squared So it's Vt minus a half At squared. And that there is the final one. And that one obviously has no U. So here they are. And like I said, this final one, like I never learned it in school. If there was a question where you required no U, then we would just use a combination of the other ones. We wouldn't create a specific formula for it. But yeah, there we have. So, you know, this one, no S, no A, no T, no V, and no U. So the final ones, you need to be able to recall them, but I don't think you need to be able to derive them. Okay, so the first two, I've never seen a question on it, but it's in the spec that you could technically be asked to derive them from the graph, but these ones I don't think is even in the spec to derive them. I think it's just to be able to recall them. Okay, and like I said in the previous video, these are known as the Suvat equations. Okay, so just obviously the letters that we use for this constant acceleration. Now let's look at one or two examples. So here's our first example. A particle is moving along a straight line from A to B with constant acceleration of 8 meters per second squared, 8 meters per second. The velocity of the particle at A is 2 meters per second in the direction of AB. The velocity of the particle at B is 24 meters per second in the same direction. Find the distance of AB. So, like I said, I always draw a little sketch, although this is, you know, quite a straightforward question. I always like to start off with a little sketch. And, you know, it's good to get into good habits now, even though that the questions are straightforward. Get into good habits that therefore then end up helping you out when the questions get a little bit more challenging. So this is 2 meters per second. This one is 24. This direction is the direction I'm going to take as positive. And the acceleration there is 5. So putting that in terms of our letters, U equals 2, V equals 24, A equals 5, S we want to find, and T we don't know or we don't want to find it. Okay, so I am looking for a formula with these 4 things. Okay, so looking back at our formulae from earlier, hopefully you'll notice that V squared equals U squared plus 2AS contains these 4 letters. So I want 3 that I know, and the one that I want to find is the 4th one. Okay, and here we have it. So any other formula wouldn't work. We'd have to then do more than one calculation. Now that we've selected the right formula, and like I say in all my videos with formulae, write down the formula every time you use it. You'll soon commit it to memory then. Right, so now it's just a matter of substituting these in. Like so. So 24 squared is 576. That's 4 plus 10s. So minus 4 gives me 572 equals 10s, and therefore s is divided by 10, 57.2 meters. And there I have it, solved the question. Nice and straightforward. Okay, but I think you'll see, once you get into these, they will get a little bit harder once you start bringing more and more stuff in. But for the beginning, a nice straightforward one. Okay, next example. So we have a particle here moving in a straight line with a constant deceleration of 6 meters per second squared. At time t equals 0, the particle passes through point O with a velocity of 18 meters per second, travelling towards point A, where OA equals 10 meters. Find the times it passes through point A and the value of t when it returns to O. So my first step is, as always, draw out a little sketch of what's happening. So my particle here is at point O. This is 18 meters per second. I'm going to take this as my positive direction. It's going to pass point A. I'm not sure when yet. Let me just do this. So 10 meters between point O and point A. What else is there? So this is t equals 0 at this point, but that's all we know. Okay, so we know that A is minus 6 because it's deceleration, that's positive direction, minus 6 in the opposite direction. We know that U is 18. We know that S equals 10. And we want to find the time t. So we want a formula with S, U, A and T, and that formula is S equals UT plus half AT squared. Okay, containing all three of the ones we know, S, U and A, and T which we want to find. So I start off by substituting my values in. So that is 18t. Now a half A is minus 6, so that'll be minus 3t squared. So that gives me 3t squared minus 18t plus 10 equals 0. And then solving that, so at this point I'm just using my calculator, but of course you shouldn't just use your calculator, just put the values in. You should actually do a little bit of working out. So what I would always suggest in these cases is, write down the formula and then stick these two answers in afterwards. Okay, so it's 2 times and both are correct. What it means is that this is going to pass point A at 0.62 seconds, carry on passing it until it slows down to 0, then starts back and it passes A then on the way back at 5.38 seconds. Okay, and then that is part A done. Now part B, we know that A is still minus 6, U is 18. We know that S equals 0, and then we want to find T. Okay, S is 0 because it's gone and it's come back. Now these are the same 4 letters as earlier, so it's going to be the same formula So s equals ut plus a half at squared. And now it's just a matter of substituting in. So 0, 18t minus 3t squared. So take 3t out, and that'll leave me with 6 minus t inside my brackets. So 3t equals 0, or t equals 0, which we know, and 6 minus t equals 0, or t equals 6. Okay, so the value when it returns is going to be t equals 6. And then we have the second question. Okay, I won't do an example with the s equals vt minus a half vt at squared, because it's the same as this example, really, just with v instead of u. But, you know, like I said, there aren't many questions that you'll need to just use that formula for. Generally, most of the questions you'll already have some parts of your answer by the time you would effectively need to use a formula like that. Now, let's jump in with the questions, and I'll try and find some exam questions for you to have a go at. And like always, the answers will be at the end of the video. Now, just before we do look at those questions, if you are yet to subscribe, please hit that subscribe button now. And if you've been here a while and you find my videos useful and you want to help me out, then please consider hitting that join button, even if it's only for 1 month. Otherwise, let's get on with the video. So here are the questions. I'm just going to give 3, and once you've done these, you should be able to try a few more from the textbooks and from questions online. Okay, so pause the video now and then resume the video to look at the answers. So here is the first one. We've got a particle moving along the x-axis with constant deceleration of 5. At time t, the particle passes through the origin O with a velocity of 12. At time t, the particle passes through the point A with x-coordinate 8. Okay, so let's start off by marking down, what's going on. So because I know I'm going to have a -1, we'll start off here at the origin, and it's going to be a velocity of 12. This is going to be my positive direction. And we're going to go to 8. It's going to be a constant deceleration, so -5. And that is what we're looking at, going towards that 8, and we need to find t. So for part A, we know u equals 12, a equals -5, we know that s equals 8, and t we want to find. So what formula has these 4? And you guessed it, is s equals ut plus a half at squared. So just substitute in now. So s being 8, and we've got 12t minus 5 over 2t squared. So multiplying by 2 and rearranging gives me 5t squared minus 24t plus 16 equals 0. And the answers are 0.8 and 4. Now, like I said before, you need to not just jump straight to the answers here. You do need to show some of your method. So either, factorize it, i.e. 5t and t, and this will be 4 and 4, won't it? Both of these being minus, and that would work then. So 5t squared minus 20 minus 4 is minus 24, and minus 4 times minus 4 is positive 16. Okay, so having that in there as your line just here would just be enough then, just to guarantee you the full marks. Don't just do what I did there and jump straight to the answer. Anyway, let's move on to part B. So the speed of the particle as it passes through the point, minus 8. So that means that it carries on up this way, and then it goes down and it carries on down that way, all the way down to a point here of minus 8. And we want to find V. V will be going in that direction, but as we are taking, we can still take the positive to the right. So, if I'm going to take the positive to the right, that would be a minus V. Okay, so it's up to you. You can change directions of your, which you're taking as positive for the second part of the question, or you can stick the same. You just have to be careful with your signs. So we've got U equals 12, A equals minus 5, S equals negative 8, and V is what we want to find. Okay, so the formula that contains these is V squared equals U squared plus 2AS. So substituting in what I know, so that's 12 squared minus plus 2 times minus 5 times minus 8. I'll put them all in like that. So that's 144 plus 80, which is 224. So V is going to be the square root of that, which is going to be 4 root 14, or 15.0. Okay, now it's obviously plus or minus at this point, but obviously at the end you could say it's minus 4 root 14, or you can say or 15 minus 15, or you could say it's that speed in the opposite direction. Okay, so it is basically 15, but because we've gone this way and then slowed down and eventually gone this way, then your speed is going to be going this way. But it all depends on which direction you take as positive, as to whether you've got a positive or negative answer there. So you could say V equals 15 meters per second, just from, in the 08 direction or something like that. Don't know how you would write it down, but towards 9 or something, but something like that, just to say which direction you go in if you want to. But I think in this kind of case, the value on its own should be enough, and the diagram helps. So, you know, if you've got like a minus sign and they've got a positive one in their mark scheme, then they'll look at your diagram to see, and your diagram's clear, like the direction, then the answer will just be the same, but obviously a different sign to what they've got. So here we've got a car travelling along a straight horizontal road with constant acceleration, passes over 3 consecutive points A, B and C, where AB is 100, BC is 300. Speed of the car 14 and at C is 20. Okay, so let's just sketch what's happening. And like I said, sketching, it's good to get into good habits with this, because, you know, when you get to the more complicated questions, the sketches, they really help. So that's B, and there's 100 meters between these. And then there's C, and there's 300 meters between B and C. Now at B, this is 14, and at C it is 20, and we will take left to right as the positive direction. So what we've got to find here is the acceleration of the car and the time it takes to get from A to C. So first of all, the acceleration of the car. So we want to find the acceleration. Now, if we go between B and C, so let me just rub that out a second. So we're looking just between B and C. So the acceleration of the car is constant, so it'll be the same throughout. U will be 14, V will be 20, S will be 300. We've got 4 pieces of information, 1 unknown, so U, V, S and A. So that's V squared equals U squared plus 2AS. So 20 squared equals 14 squared plus 2AS, so that's 600A. So 20 squared is 400 minus 14 squared. So that leaves me with 204 equals 600A. So A is 204 divided by 600, or 0.34 meters per second squared. Now, part B, we need to go from A to C now. So in this case now we don't know U. Okay, we know V is 20. We know that S is 400. We know that A is 0.34. And we know that T, we want to find T. Yeah. So we're using our answer to part A for part B. So the formula for this one is S equals VT minus a half AT squared. Okay, so that is, S is 400, and that's 20T minus a half AT squared, so minus 0.17 T squared. So rearranging it, and of course using the formula. So, you know, for this case, make sure you do write the formula down, you know, at least fill in the values. even if you're just plugging these numbers straight into your calculator. So it gives me two answers. And the problem with two answers is that while you can work out which one is the correct answer between these two, it's kind of logical but not necessarily obvious. So the correct answer will be this one, and it's because, and I'll show you why, and I'll show you a slightly different way of doing it, but because when I work out the initial velocity at A, okay, it is going to give me basically a positive or a negative answer. And because this is a car travelling along a straight road, unless the car was first reversing and then started going forwards, it would mean that the positive answer would be the one that you want. So with a positive answer, it would take 25 seconds, 25 and a half seconds. Okay, but if this was a negative value first, it would obviously take longer because it would take time to get from the negatives to 0 and then into the positives, which is where this time would come in. Okay, so the answer is t equals 25.55, assuming not in reverse at A. Okay, but let me just show you another way of doing it. So instead of working out t first of all, let's work out u. So now we're going to use v squared equals u squared plus 2as. So v is 20 squared, u squared we want to find 2 times 0.34 times 400 there. So that gives me 400 u squared plus 272. U squared equals 128. Therefore u is plus or minus 8 root 2. Which is 11.3. So now assuming car is not in reverse, u equals positive 8 root 2. So now we can use v equals 20, s equals 400, we've got a equals 0.34, and we've got u equals 8 root 2, and we want to find t. So v equals u plus at, so 20 equals 8 root 2 plus 0.34 t, and then that's 20 minus my answer, which is 8.7 divided by 0.34, and then it gives me that t equals 25.5 or 25.55 seconds. 25.5479 it is. Okay, but now you can see that that is the correct answer. Okay, had I used the negative one, this would have given me the 92 second answer. Okay, and in the past we wouldn't have used s equals vt. We never used that when I was in school. We always did it like this way, using two formulas in cases like that. So just be careful with those, and sorry about the squeaking in the background. I've got a 3-month-old puppy who is having a massive play. Right, let's look at question 3. So we have an orienteering comp, and the competitor moves in a straight line past 3 checkpoints, P, Q and R. And these are the distances. It takes 1 hour to travel PQ and 1.5 hours to travel from Q to R. So let's look at what's going on. So we've got P, Q and R. So this is T equals 0, T equals 1 and T equals, this will be like 2.5 because it takes 1.5 hours between Q and R. And then in terms of velocities, we don't know any. We'll take this as the positive direction. And this is 2.4 kilometers. And this is 11.5 kilometers. Now, since I don't know any velocities, I'm going to call that VQ, VR, and VP. Okay. Now, VQ is the one that I want to deal with because it appears both between P and Q and Q and R. So between P and Q, V will be VP, time would be 1, distance would be 2.4, and A is what we're looking for. So I can use this to get me an expression in terms of VQ, that should be. So S equals VT minus a half AT squared. So 2.4 VQ times 1 minus a half A times 1 squared. Okay, so this will give me VQ equals 2.4 plus a half A. Now let's look between Q and R. So between Q and R, U is VQ, S is 11.5, T is 1.5, isn't it? 1.5 hours between Q and R. What else do we know? Oh, and A, which is what we want to find out. So we need a formula again, and this time it will be S equals UT plus a half AT squared. So S is 11.5, and then it's 1.5 VQ plus a half A times 1.5 squared. So that means 1.5 VQ is 11.5 minus 9 over 8A, and then divide by 1.5. So VQ is 3/4, 11.5 divided by 1.5 gives me 23 over 3. So now I've got two expressions for VQ, and when I equate these two, because they're the same answer, I'll then have just an expression with A in it. So equating these, we get 2.4 plus a half A equals 23 over 3 minus 3/4 A. So a half plus 3/4 gives me 5 over 4A, and then 23 over 3 minus 2.4 gives me 19 over 15. So divide that by 5 over 4, and A is, well, as a fraction is 316 over 75, but as a decimal is 4.2 or 4.21, and then 3 recurring. Now I'll store that in my calculator as A, because I'll need the full exact value for what I'll when I answer in part B. So part B, now we want to find VP, which is U. That was my VP, but I can just leave it as U, because that is what I want to find. And then I want, so this I want to do between P and Q. So time equals 1, distance equals 2.4, and acceleration equals 4.2, but use exact value. Okay, so for that, use exact value. Okay, don't use the 4.2. So S equals UT plus a half AT squared. So 2.4 equals 1U plus a half times 4.2 times 1 squared. So U equals 2.4 minus a half of my answer. And that gives me 22 over 75, or 0.29 or 293 meters per second to 3 significant figures. Sorry, not meters per second, kilometers per hour. Okay, because the distance is in kilometers and the time is in hours. So just be careful of that. If I wanted to put it into meters per second, then I would times by 1,000 to put it into meters, and then divide by 60 times 60. And it'd be 0.0815 meters per second to 3 significant figures. Doesn't say to put it, give the answer in meters per second. Okay, so, you know, it's fine there, but that is how we would do it. And that is the final question. Okay, so come back next video for vertical motion under gravity, and hopefully, like I said before, hopefully you got some use out of this video. If you did, comment down below, especially if I made any silly mistakes, as I often do make the odd little errors here and there. But otherwise, I'll see you next time.